So for this video, we're going to kind of continue along the lines of accuracy and precision and talk about significant figures. Some people call them sig figs. Some people including me. So what sig figs do, they reflect the precision of a measurement. So sig figs, we're talking about precision, how precise the measurement can be. And the way they work, more sig figs means a more precise measurement. First, we're going to talk about how to count sig figs, and then I'll tell you what the purpose is and what it means. So step one, when you're counting the number of sig figs in a number, you just look for the decimal point. So if the decimal point is absent, meaning if there's not one, if it's absent, think Atlantic Ocean. If decimal is absent, think Atlantic Ocean. If the decimal point is absent, I want you to think Atlantic Ocean. Alright, you're probably thinking, why the heck are we talking about geography? This is science. I realize that. Bear with me. So the rule is, start with the first non-zero digit and count all digits after that. So let's look at an example here. Let's say we have a number like 120. Alright? The decimal is absent, so we're going to start on the Atlantic Ocean side, over here, the right side. We're going to start with the first non-zero digit, so we'll skip this one, and count all digits after that. So we have 2 sig figs. 2 sig figs in that number. Alright? So let's look at another one. What if we have, let's do 4,050. Alright, same deal. Decimal absent, start on the Atlantic side. Start with the first non-zero digit. 1, 2, 3. 3 sig figs in this number. So on the flip side, sometimes you'll have a number that does have a decimal. So if there is a decimal, let's say we had a number like 1.20 instead of 120, there is a decimal, so we say the decimal is present. Start from the Pacific side, which would be over here. And then you do the same thing. And as it were, the rules are exactly the same. You start with the first non-zero digit and count everything after that. So let's stick with this 1.20 we've got. So decimal present, we'll start on the Pacific side. Start with the first non-zero digit, which would be the 1, and count every digit after that. So 1, 2, 3 sig figs in 1.20. Okay? Let's say we had a number like 0.0079. Alright, the decimal point is present here, so we're going to start on the Pacific side. Start with the first non-zero digit, so we'll skip these zeros. 1, 2. 0.79 has only 2 sig figs. So at this point you're probably thinking, what's the point? Why do I have to worry about writing it to a certain number of decimal places and then significant figures? What's the point? Well, I'm going to tell you what the point is. Like we talked about before, in science it is extremely important to only report your measurements with the accuracy and precision that you measured them with. So you never want to give more decimal points than whatever your measuring tool you used. And you never want to give fewer because you want to reflect as much precision as you can. So what that means is, sometimes you have to round to a certain number of sig figs to get the right amount of precision. Let me show you what I mean. Let's say we had a number like 125,462 grams. And that number is really, really precise. It's possible that whatever it was measured with is that precise. But we're going to say we only want this answer reported to 3 significant figures. So that's your goal. Take this number right here and make it to 3 significant figures, because right now we've got 1, 2, 3, 4, 5, 6. That's too many. So what you're going to do, this is pretty easy. You're going to go to the third digit. Let's see, 1, 2, 3. There we go. So we're going to round to the 5 because that's our third digit. So we're going to keep these 3 numbers. Now, rounding works with sig figs the same way it does with anything else. When you look at the number you're going to round, which is this guy right here, look to the next number. If it's above 5 or above, then this number is going to round up. If it's 4 or below, then this number is going to stay the same. So right now we got a 4. So our 5 here is going to stay the same. Everything else, you just leave the way it is. So now we got 3 sig figs, right? So if we write our answer, 125 grams, right? Well, something's wrong here. Because the whole point of sig figs is you're supposed to have the same measurement. You're just showing it with less precision. So up here we've got 125,000 something. And now we've reduced it to 125 grams. Something weird's going on there. So what we need to do is rewrite it this way. The 1, 2, and the 5 are right, but we need to have placeholder zeros to replace these numbers. We cannot lose those digits. So this is the right way to write that measurement. If you look, what we've done, we've rounded this number down to this number. What we wanted to do was get less precise. We only wanted precision to 3 sig figs. Here are our 3 sig figs right here. All these zeros out here, these are just placeholders. We have to put them there just so our number will stay the same size, stay the same amount. Those are placeholder zeros. So let's try a couple examples. Let you guys practice a little bit. Alright, so what I want you to do, try to count the number of sig figs in each measurement, and then I want you to round that measurement to 3 sig figs. So take each and every one of these measurements and round it to only 3 significant figures. So I want you to pause the video right now. Once you've worked the problems, you can unpause it and watch me solve them. Alright, so the first measurement, 1.342. We're going to go to our third digit, which is the 4. 2 is the next digit, so that means the 4 will stay the same. So we round that to 1.34 kilometers. Now we have 3 sig figs and we've got the same measurement, just slightly less precise. Alright, next is 2.695 inches. So the 9 is our third digit. We look to the next digit and we got a 5, so the 9 rounds up. So this is a little interesting. Since the 9 rounds up, it goes up to 10, which means the 6 also has to go up. So we're going to end up with 2.70 inches. Alright, 2.70. So now we've got 1, 2, 3 sig figs just like we wanted. So let's do the next one, 5,892 feet. We go to the third digit, which is the 9. The 2 is going to make it stay the same, so we can rewrite as 5,890 feet. Now we've only got 3 significant figures, so we're good. Alright, our next number, 0.000721 grams. Alright, so what we're going to do, we're going to go to our third digit, skip these zeros, because if we rounded here, we'd end up with 0 for our answer. So we're going to start here. 1 is our third digit. So if we look at this number, we've already got 3 sig figs. So that was kind of a tricky one. This is already 3 sig figs, so we're good the way it is. Alright, next one. This was actually kind of a tricky one. So if you got it, great job. So our third digit is this 9. The 7 causes the 9 to round up. When the 9 rounds up, this next 9 has to round up, which makes this next 9 have to round up as well. So we're going to end up with 10,000 millimeters. It's a 0, 10,000 millimeters. And if you look at our two numbers, it kind of makes sense, right? 9,997 would round up to 10,000. It's the same thing, just a little bit less precise. Now, we rounded like we were supposed to, but now we've ended up with only 1 sig fig. So something weird's going on here, because these zeros are insignificant. But we wanted our answer in 3 sig figs. So what you do, in this case, you need to make a 0 significant. To be able to make a 0 significant, you put a bar over it. That bar means that 0 is significant. So basically what the bar there is telling you is count this 0 here, because we need it to be significant. So if we count the sig figs in this number, now we've got 1, 2, 3, which is exactly what we wanted. Okay, so if you're in my class, We practice this a lot in class as well, and you will be required to know how to use sig figs throughout the year. It is very, very important. I realize it's not the most exciting thing in the world, but you got to know how to do it. It's just one of those things. I hope this video helped. There's a lot more out there, so if you feel like you need more practice, go for it. Good luck.